Greetings, Earthlings. All right, I've got the new resistors in. Let's see, there are the resistors there. Replacement resistors. Got 10 of them. I didn't have that particular value in stock on hand. Whatever. So it turned out there were two resistors. This one here and this one here. Which are these two right here, that were 392K in the schematics, but they put a 118K in there. These are and what was in there was like a mil spec. It's an RN55D, which is like mil spec with a 1972 date code. So I have to believe that it was a situation where they just didn't have any, they couldn't get, for whatever reason, 392K resistors, and they wanted to ship units, so they kludged around it and worked with what they could get. Here's that. Here, can you see this? Yeah. Here's this other one. Okay, this is the one we were looking at that's part of the integrator, and here's another one which is part of the zero adjust. So I'm putting 20 volts in now on the 10 volt scale. You can see it's counting to nearly 20. Over here you can see the output of the analog card from the back, which should be about 2 volts. Here we see the value on that integrator capacitor, and it's 10.3 volts, which is where they wanted it to be, where they designed it to be. Definitely well within the clipping range. If I go to 30 volts, you can see there it's clipping now, right? And of course, it indicates overload and blanks because of that jumper blanks the screen. Okay, so it needs to be calibrated. Yeah, we'll get to that. That'll be a video all on its own, I think. Let's see how it does. Well, this should have fixed the resistance measurement. Let's verify that. So this is the 20 megohm. I don't want to be on the 20 megohm scale. Let's go to the, here we go, 100K ohm scale. There's 100K. There's 100K. Yeah, and it's reading low because the DC voltage needs to be calibrated. But, and over there you can see that's closer to 1, which is what you would expect on the output. 100K. And here's 200K. And again. Yeah. Working but out of calibration. AC volts. AC volts was not working. I was getting no reading. So let's check that. Here's 10 volts AC. Huh. This is 10 volts AC on the 10 volt scale. No, not so good. Okay, that's interesting. It reads 1.3. Then I give it 10. What if I give it 1? Oops, there's 1 volt AC. Nothing. No range. No range. It should go blank. Why is it not going blank? I don't know. 1 volt scale. 1 volt. This is at 1 kilohertz. I don't know. I can go to 100 hertz. You see, that makes a difference. No. The output there is like 0. So, back to 10 volts. Yeah, So the AC converter, which is on this board here, is once again, well, still not working. So that's the next thing to look at. All right. So the AC converter is pretty simple. I don't know if you can see that. Maybe you can see that. There's an op amp here. It has two test points on it. Okay, test point 23, test point 24. The Keithley is reading at test point 23 right now. This is with 0 in. If I change it, let me set the, yeah. If I set it to standby, that would be 0 volts in. Got 14.3 volts. If I set it to operate, same deal. I'm at 1 volt in right now. This is with 2 volts in. It doesn't change. That's stuck at the rail, basically. So that says maybe this op amp is suspect, huh? Have to have a look there. Again, it's a pretty simple circuit. So there can't be too many. I guess this is the voltage coming in. I have to trace it back, but I'm guessing that's the voltage coming in. And this is connected to the plus 15 volt rail right here. Oh, so potentially this could be bad, because if that's turned on, fully on, that's sending 15 volts through there to there. So it could be there, it could be there. Have to have a look. All right, so off camera, I verified that the basically that the AC voltage divider is working okay by putting 2 volts in and checking the output on the back panel underneath. So at this point, what I've done is I'm on the AC converter now, and I'm looking at pin 4 of QA1101. I know you can't see this. I'll put up something. So if I have 2 volts coming in at the input jack, I should see 0.2 volts coming in here. This is just like a, I want to say emitter follower. It's a source follower because it's a FET. So we should see the 0.2 volts here on pin 4. And recall that the output, pin TP23, is basically hard up against the plus 15 volt rail. So let's see, I have 0 volts coming in right now. You can see that it's at roughly 0 volts. I don't remember whether I did AC calibration on that Keithley or not when I fixed it. But anyway, I'm going to turn on 2 volts. And okay, there's my 0.2 volts. So it looks like Q1101 is okay. It sure looks like that op amp is the problem. Again, that's a 715, UA 715. I don't know who made those. Fairchild? Yeah, Fairchild, huh? Oh, look, I have 3 of them. Huh, what do you know? These have 74 date codes, which is what the original has. It's 7405, 7405. What's my third one? 7405. What do you know? Yeah. Looks like that's got a... Oh, bad idea. Looks like that's got to be replaced. All right, I'm going to pull this card out, which has the AC divider and whatever circuitry on it. And to do that, and I'll show this in great detail because I know there's somebody on the EE blog forum who has one of these that he's looking to fix. And he was worried he had to remove the knob from the front panel. But as you can see here, there's a coupling right there, and it will slide right out. If you set that, what am I on? I'm on the 10, like 10 volts, and there's one screw on the bottom side. Is there another screw? There's another screw. There would be another screw. Okay. I stand corrected. There are 2 screws holding that board in. In this case, one of them is a Phillips and the other is a flathead for no good reason. Okay, now it should just come right out. Yes, there you go. See that? Let's see. 1, 2, 3. Oh, well, I'm going to disconnect that from that board there, and that's all I have to do. Okay. Oh, except, okay, hang on, just a minute. There's 3 wires down here that are on pins as well. So it goes white, red, blue. Okay, and there is the board. There's the board out of circuit, and you see that pin just stays there. It's not going anywhere. Okay, this is the AC stuff over here, and let's see. AC converter, AC voltage divider, and this is the range selection for everything else, I guess. Or for the DC divider is on there, those resistors. All right, and here it is all back together. Well, I haven't screwed that board in yet, but I replaced the op amp, the 715, with a vintage clone. It's a 7405. This was 7352, so it's just 6 weeks later or something, 5 weeks later, whatever. So let's see if that had any effect. I'm on AC volts again. I've got the Fluke 5200A set to output 2 volts right now at 100 hertz. It's currently outputting 0, so let's switch on and see what we see. And that's somewhere around 0. Obviously needs adjustment even if it is working. Let's turn the 2 volts on. Oh, this is, hey. Wow. I would say this is 3 volts, 4, 10. I would say that's working again. Well, again, yeah, who knows when it last worked. Okay, 10, I can go to 20 on this scale. Well, let's see. That's 10. That's 10. That's 20. Yep, okay. So back in business. Hopefully, calibration adjustment will bring it back into spec, but I think we're basically done with the repairs.